Hello everyone. Today I have a video here. I'm going to be showing you guys how to solve an equation in vertex form. So we got a problem here to start with. We're sketching the graph of this function and it's in vertex form. So to start out, what I'm going to do is I'm going to write the equation over here on the side. So we have y is equal to 2 times x plus 4 squared plus 4. So that's our equation. The first step in graphing each vertex equation is just to find a vertex. I know, shocking, right? It's like in the name or something. So to find the vertex, we got to remember that vertex form is actually y equals a times x minus h plus k squared, x minus h squared. And then so to find the vertex, we're going to look at the h value and the k value. And so in our equation, the h and the k are both 4s. But we got to remember that x minus h is, we have a plus 4, so that's the same thing as x minus negative 4. And so when we have a plus, we know it's actually going to be a negative, which is kind of confusing. So our vertex is actually going to be negative 4, and then we have that plus k or plus 4 for the y value or the k value. And so our vertex is going to be negative 4 comma 4, so we can go ahead and graph that here on our little graph. So we have negative 4 comma 4, which is going to be right about there on our graph. Okay, so after we find the vertex, our next step is going to be looking for our next step is going to be looking to see if our graph smiles or frowns. And so to do that, we're going to look at our a value here on our graph, which for us is 2. So when we look at our a value, we're looking to see is our a value positive or is it negative? And so obviously 2 is a positive value, which means that our graph is going to be smiling. So it's going to look something like that. And so when we look and see that our graph is smiling, we notice that it's actually not going to cross this x-axis right here, which means that we're not going to have to worry about finding zeros or x-intercepts. So instead of looking for x-intercepts, I'm going to look for a y-intercept, which would be along this line right here, some point along there. And when we're on the x-intercept, you can see that x is actually going to equal 0. And so when we set x equal to 0, we're saying, okay, what's y going to be? What's our y coordinate? And so we can just use our equation setting x equal to 0 and solving for y. So we have y equals 2 times x, which we're going to set as 0, plus 4 squared plus 4. And now we just need to solve for y. So to solve for y, the first thing we're going to do is follow order of operations. So we have the stuff inside the parentheses first. So we have y equals 2 times 0 plus 4, which is just 4, squared plus 4. The next thing we do is exponents. So we have y again equals 2, and 4 squared is 16. So 2 times 16 plus 4, and then multiplications. So y equals 32 plus 4, or y equals 36. And remember, to get 36, we plugged in 0 for x. So this is actually going to be a coordinate of 0, 36. And that is our y-intercept. So let's take a look at our graph. We have 0, 36. Well, if we look at our graph, 0, 36 is going to be like way up here somewhere, and we don't even have that on our graph. So I'm not going to plot that point. So instead, I'm going to look for one that's maybe a little bit closer to the vertex that we can actually plot. So let's go ahead and erase here. And let's take a look at a different coordinate. So maybe instead, let's look right here on this line where 3 is at. Maybe there's going to be a point that's a little bit closer and we can actually plot here. So let's say, let's assume x is equal to negative 3. And then we'll try to figure out what y is. So let's do the same thing that we did, but instead of 0, x will be negative 3. So we have y equals 2 times negative 3, or x, plus 4 squared plus 4. And we're going to do the same thing. So we're going to do inside the parentheses, y equals 2 times negative 3 plus 4 is 1 squared plus 4. Y equals 2. 1 squared is just 1 plus 4. 2 times 1 is 2 plus 4. So y is equal to 6. And again, we got that because we set x as negative 3. So negative 3 comma 6. So that's a little bit better if we look at our graph here. Negative 3 is right here, and then 6. So we can plot that right there. And I'm happy with that. We can actually see it on our graph. And then if we remember, since our graph is going to be symmetrical, we can actually just look, since we went one to the right of the vertex, we can go actually one to the left of the vertex and plot at the same point. So we can put another point right there. So now we have 3 of our 5 points. So let's plug in one more value for x and see if we can get another point that we can plot on our graph just to make it more accurate. So we got 3 there. So let's take a look on our graph. I'm thinking if we plug in -2, we can get another point right there, somewhere along that line. So let's do that. So if we say x is equal to -2, what is y? So we do the exact same thing that we've done the last 2 times. Y equals 2 times x, but this time it's -2 plus 4 squared plus 4. We start with inside the parentheses. 2 times -2 plus 4 is 2 squared plus 4. And then we do the exponents here. So y equals 2 times 2 squared is 4 plus 4. 2 times 4 is 8 plus 4, because we always do multiplication first. So we have y equals 12. And again, we got that because we plugged in -2 for x. We have -2 comma 12. And that will be our next point. So -2 comma 12 is way up here. And since we moved 2 to the right of the vertex, we can also move 2 to the left of the vertex and plot that same point way up here on the other side. Alrighty, so now we have 5 points. We can go ahead and sketch this parabola. So let's go ahead and do that right now. So we kind of go up through these points and then over like such. And there is our parabola. It looks amazing. So that is how you can use vertex form to sketch a graph. So step 1, find the vertex. Step 2, is it smiling or frowning? Step 3, either find the y-intercept or the x-intercepts, and then find some other points that we can plug in and try to make that graph accurate. So let's look at another example down here. This one, we got y is equal to -2 times x minus 3 squared plus 4. So this one's going to be a little different. So the first step, we're going to find the vertex again. So if we remember, y equals a times x minus h squared plus k. So if we're going to look at the h and the k, this time the vertex is going to look like this. So it's going to be our h value, which is 3. And since it's subtracting 3, we know it's just going to be a regular 3 because we're subtracting h. And then plus k or plus 4. So 3 comma 4, that is our vertex. So if we zoom in our graph here, we have 3 comma 4, which is right about there. Okay, so now we have our vertex. We want to look to see if our graph is smiling or frowning. And to do that, we're going to look at our a value, which in our case is -2. And since -2 is a negative number, that means our graph is going to be frowning. So it's going to look something along the lines of that. Not perfectly, but yeah, you get the idea. This means that this time it is going to cross the x-axis, which means we do have x-intercepts. And unlike in standard form, we can't use the quadratic formula to find our x-intercepts. Instead, what we can do is, since we know our points are always going to be something, comma 0, since we're always going to be on the y-axis, what we can do is plug 0 in for y and figure out what our x coordinates are. So to do that, we take 0 and set that, or y, and set that equal to 0. And then let's write out the rest of the equation. -2 times x minus 3 squared plus 4. Okay, so now we are going to solve for x. So we want to get x by itself. So the first thing we're going to do is subtract 4. So let's go ahead and do that from both sides. That's going to cancel. So we have -4 equals -2 times x minus 3 squared. So the next step is going to be dividing by -2, and that's going to get rid of that -2 there. And -4 divided by -2 is just 2, equals x minus 3 squared. And to get rid of a square, we're going to take the square root of both sides. So that gets rid of both of those. So we have the square root of 2 equals x minus 3. And last step is to add 3 to both sides, like such. And we are left with x equals the square root of 2 plus 3. And if you take out your calculators and put square root of 2 into your calculator, you will find that the square root of 2 is equal to 1.414, about. It's about 1.414. But since it's a square root, we actually know that it's going to be plus or minus 1.414 because even negative 1.414 squared is the same as 1.414 squared. So now we're going to take the two versions, so 1.414 plus 3 and negative 1.414 plus 3. And this will give you 4.414, and the other one is 1.586. So these are going to be our two numbers here, and those correspond with coordinate points. So that would be 4.414, comma 0, and 1.586, comma 0. So now we can go up here and graph those. We're just trying to get a good accurate estimate here. So 4.414, so that's about right there. And then 1.586, which is about right there. So there's 3 of our points. So now I'm going to go ahead and erase, and let's look for 2 other points that we can use to make our graph just a little bit more accurate. So let me go ahead and erase here. Okay. So since we got our x-intercepts, I'm going to go ahead and look for a point along this 1 column right here when x is equal to 1. So let's go ahead and set x equal to 1 and y we don't know. Okay, so let's take a look here. So y is equal to negative 2 times x, which we're going to set as 1, minus 3 squared plus 4. And now we're going to solve for y. So do the parentheses inside the parentheses. So y equals negative 2 times negative 2 squared plus 4. And negative 2 squared is the same thing as 2 squared. So negative 2 times 4 plus 4. And then we take y equals negative 2 times 4, which is negative 8 plus 4. And that's the same thing as negative 4. So that was when x is equal to 1. So our point is 1 comma negative 4. So now we can go up here and plot that up here. And since that was 2 to the left of the vertex, we can also go 2 to the right of the vertex and plot that. And now we have 5 points on our graph. So we can go ahead and draw that graph. And we have an accurate graph that we can draw. So just to remember, to sum it up, when you are in standard form, or excuse me, in vertex form, step 1 is find the vertex. Step 2 is, does the graph smile or frown? Step 3, find either the x-intercept or intercepts or the y-intercept. And then step 4 is to find other points that we can use to make the graph more accurate, because we're going to want about 5 points every time just to get that accurate version of the graph. So I hope this video helps you guys just to understand how we can use vertex form to graph an equation. I hope you all have a good day. Bye-bye.